All right. So once you know how to determine what's a nucleophile, what's an electrophile, the next step is we're gonna draw the curved arrow to finish drawing a reaction mechanism. But let me explain real quick. So what's a reaction mechanism? Mentioned a couple times, but the reaction mechanism is the way a chemist explain how a reaction works. This atom go bond with another atom, this bond break, this bond is formed. So we use arrow to show that from a nucleophile and electrophile. Okay. Now, give you some example right here. So drawing curved arrow to represent bond forming and bond breaking. All right. So you should be able to identify that this oxygen here, that's a nucleophile. Who's an electrophile? In this case, there are two electrophilic center. We have this carbon in the middle right here, and that hydrogen right there. All right. And if you look at the product, looks like that oxygen from a bond with the hydrogen. Right. So this hydrogen, this proton right here, this guy is a nucleophile. You look at the product and you can tell. Okay. So bond forming, we use draw a curved arrow from a nucleophile to an electrophile. That's a bond formation. Okay. Atom to atom, basically, or to be a bit more accurate. So from a lone pair or from a negative charge is a lone pair, same thing, right? So a lone pair to an atom, right? Or atom to atom, the same thing there. This curved arrow represents bond formation, and we use another arrow to represent bond breaking. This bond is break and become a lone pair on the oxygen. So two lone pairs on the oxygen become three lone pair. This lone pair is a new one from the bond. Okay. Notice that I draw from bond. This is from bond. Start from bond, go to oxygen, because these two electrons actually break this bond. Not break this bond, but these two electrons become a lone pair on oxygen. All right. So we have an atom to atom, an atom to bond. All right. Again, I can't say this many times. So every time when I teach organic chemistry, at the end of the course, 25% still draw the curved arrow wrong. Right? And do not do this. This doesn't make any sense. Again, the curved arrow represent electrons movement, right, from nucleophile to electrophile. Does not show how atom move, right? It's tempting to draw a proton hop on the other oxygen, but this doesn't work that way. If you draw an arrow like this, you cannot explain how come this lone pair is gone. Three lone pair become two lone pair. You can't explain that. How do you explain this atom breaking? Right? Two lone pairs right here become three lone pairs. This doesn't make any sense. So we need to use an arrow appropriately, which is draw represent electron formation. No, it's not electron movement. Okay. All right. Now, there are four main types of mechanism that you're gonna see. Okay, so we have this four. We have nucleophilic attack, loss of leaving group, proton transfer, and rearrangement. And you're gonna see all these together separately or whatever, and different atoms, bonds, nucleophile, different electrophile. You see all this, but all mechanism that you're going to draw from now on will be some of this. All right. So don't memorize this, please. Don't flashcard this. You can't really flashcard them, because I can change bromine to chlorine. I can change this carbocation to some others electrophile. Right? I can change all the substrate. I can change all the product. You can't memorize this. You have to recognize it instead. Okay. All right. Let's start with the first one, nucleophilic